Hi, thank you all very much. This is Ben Bollen, blockchain scientist at OST, and I'm Jason Goldberg. Just want to say, first of all, thank you very much to the team at UpBid for organizing this conference and for putting such a great program together. Also want to say a huge thank you to the team at OST, 65 persons strong, in New York, Berlin, Pune, India, and Hong Kong. It takes a lot of people and a lot of hard work to put these projects together, and we're super thankful for everyone's efforts on behalf of OST. And also thank you to all of our advisors, particularly a gentleman named Mark Bonchek, who contributed to some of this presentation, and to the awesome OST community for all your support and enthusiasm and work on the project. We're a pretty humble group at OST. We focus more on hardcore technology, building blockchain infrastructure, more than shouting about results. And what we want to do today is to really tell the story of a new protocol that we've been developing called OpenST Mosaic. OpenST Mosaic is a follow-on from a protocol called OpenST protocol that we announced and released in September of last year. And OpenST Mosaic is a protocol designed to help scale blockchain economies to billions of users. And we know that billions is a very big word, but we're talking about how do we bring mass consumer, mass market audiences onto blockchain. So in terms of presentation today, we're going to go through three things. First, I'm going to breeze through a couple of really context slides around putting all this into historical context and what blockchain economies are in the context of history and where we're headed, and then talk briefly about some of the barriers to mass adoption of blockchain. And then Ben's going to do a highly technical talk on OpenST Mosaic protocol, how Mosaic is a viable solution for scaling blockchain economies on-chain to billions of users, to tens of thousands of transactions per second. Ben presented the technical details on Mosaic last week, on Friday, at ETH Berlin for the first time. It was received very well by that audience, and we're really out here right now soliciting community feedback so we can strengthen the proposal and bring it out to the market. So to put all this in context, this picture here is from 1439. This is the Gutenberg printing press. And if you think about what the Gutenberg printing press started in 1439, was 500 years of revolution, industrial revolution, that impacted all facets of society, from how we spread knowledge, from how we manage relationships, to how we print money, and to the institutions that govern society. And if you look at 500 years later, we had in 1993 a different Mosaic. We had the Mosaic browser, which really foretold the internet revolution. And in perspective of it, we're still very early in this cycle, in this internet revolution. And blockchain is a continuation of the internet revolution. We don't view it as a whole new revolution. We kind of see it as it's basically a continuation of what started in 1989 with the World Wide Web, and really moving from relationships, from knowledge, relationships, and the next things will be money and institutions being reinvented as we go from analog to digital, from one to many to many to many, and really start to impact money and institutions. And we're still very early in this cycle. But if you think about it's a natural progression, if you think about what's happened over the last 25 years, the first thing we had to do was get everyone and everything online. And then we put a supercomputer in everyone's pockets. So you think about we're carrying today around a very high-power supercomputer in every single person's pocket. Then we began to redefine relationships and how people connect. And now we're starting to redefine money. And from that, we'll also redefine institutions. And from that, what become really interesting is also creating new economies. So all the photos that you saw so far are from a company called Unsplash. Unsplash is one of our partners, and Unsplash is creating a new economy around photography on the blockchain with OST, Open Simple Token, and our technology. And to put in perspective and why we're talking about billions, so Unsplash has 1 billion API calls every single month from people using its service. They have over 8 billion photo views per month. And we want to bring all of those events onto a blockchain to help them turn a community of photography or into a new economy around photography in a decentralized manner. So we're still very, very early in this revolution. It's very, very early days. If you think about worldwide today, there's, by most accounts, about 25 million crypto wallets in the entire world. And so put in perspective, Unsplash, which I mentioned, has about 70 million users, but that pales in comparison to the overall internet population. So we still have a long way to go in order to scale this. And so the three factors that are limiting adoption of blockchain really are three things. One is developers. We need a global developer community working on blockchain. Ethereum right now is the best global developer community, and it's growing every day. And these conferences like this are key to promoting development on blockchain, but we're still very early in the development cycle. The second thing is we need scalability, and the third is usability. We all know that there's usability challenges, whether it's in terms of wallets, private keys, the technology itself, but you really can't get usability until you have scalability. If you think back to the picture I showed you of the Mosaic browser, there's a reason why the UI was so ugly back in 1993, because the protocol itself for the internet had not matured enough for the scalability needed, and the bandwidth hadn't matured enough in order to handle what we know as the internet today that we carry around on our supercomputers. So today we're going to talk about OpenST Mosaic and how do we bridge the scalability gap for both apps and dApps. And when I say apps and dApps, I mean for mainstream applications like Unsplash that have billions of transactions they want to bring online, and for the distributed applications that are starting now that are going to be built for the future. You might ask, why are we building this on Ethereum? Three reasons. One is the smart contract nature of Ethereum, programmable money. We think it is the best platform to develop on, the best platform to build at scale for both apps and dApps. The second is that it actually works today. And so the proof of work mechanisms inside of Ethereum today are really safe and secure and really solid for sealing transactions, for finalizing transactions. And as I said, it's the strongest development community, and so we wanted to go where the developers are. So the problem that we're trying to solve is how do we bring existing mainstream apps that have millions or tens of millions or hundreds of millions or even billions of users onto a blockchain. But the challenge today is those blockchains don't scale yet. All right? And when we say scale to thousands or tens of thousands of transactions per second. And guess what? dApps, distributed apps, they have the same problem, right? So what we need to do is we need to provide an on-ramp for existing apps that have these tens of millions of users, and also enable scalability for emerging dApps. And what our team challenged ourselves over the last year is how do we figure out a way to do this now, rather than waiting 5, 10 years for this to happen. So last year at this time, a year ago, we introduced the OpenST protocol. And OpenST protocol is a method for staking value tokens on Ethereum, for minting utility tokens on auxiliary chains. And what this does is essentially move the bulk of transactions for high volume apps off of public Ethereum onto auxiliary chains, but it keeps them on chain. So it's still with a public validator pool. And what it does also is retain Ethereum because of the smart contract framework. And what it also means is that it provides a way for companies that don't have blockchain developers to create blockchain economies. So you actually, through the OpenST protocol, you can mint a token without ever doing an ICO. You can manage a blockchain economy without having to deal with the regulatory or technology challenges involved with an ICO, all based on the OST-based token and then scaling on these auxiliary chains, but do so on-chain. And it's also a way to scale dApps now as well. So that was a year ago. And today what we're presenting is the OpenST Mosaic protocol, which is the next step, which is how do you run what we call meta blockchains on Ethereum to scale distributed apps to billions of users. And Ben's going to talk about how this actually works. We're going to get into very detailed specifications. But there's basically what we're talking about is two things. It's how do we finalize transactions on the auxiliary chains and then commit those transactions asynchronously onto ETH, onto Ethereum, so that we can seal those transactions on public Ethereum. So Ben, over to you. Let's go through it.
Thank you very much, Jason. Thank you, Upbit. So yeah, it's an exciting announcement we're trying to make today because we all know the limitations to scaling blockchains is the full replication. At the same time, it's also where we derive the correctness from, right? By validating all the transactions, we know that we have achieved the same end result. So earlier this year, Vitalik also posted on the wiki of Ethereum on sharding blockchains. And in it, he lays out his vision for Ethereum version 2, right? And if you read it, there's 3 ingredients that are somewhat obvious. If we want to move away from full replication, we need to divide the work into shards. We need a way to be able to communicate between those shards. And we need a form of economic finality on each of those shards. And when you want to apply that to the layer 1 Ethereum, that's what you get. You get the roadmap for Ethereum version 2. What we're going to talk about today is what happens if you take those ingredients and you apply them at layer 2 in the smart contract layer. What do you get? As a brief context, there are other layer 2 scaling solutions, like Plasma, for example, is a way to scale a single smart contract on Ethereum, but then you do not have a direct way, or it's not yet obvious how you would talk between Plasma chains. For example, take payment channels, then you don't have an Ethereum interface, so it's very hard to, or you lose the programmable money. You cannot, in general, program against the payment channel. And so Mosaic is a way of composing new state spaces into Ethereum on the existing Ethereum proof of work that we have today. So what is Mosaic? I'll try to explain these concepts to you today in the remaining minutes. So OpenST Mosaic is a consensus protocol, and it's a consensus protocol to run what we call meta blockchains. Blockchains on top of a blockchain, so we run meta blockchains on top of Ethereum. And each of these meta blockchains runs in parallel and injects a new state space into the Ethereum state space. Importantly though, these meta blockchains are secured by Ethereum's proof of work. So we leverage the proof of work that we're already expending to secure these meta blockchains. And then all transactions that happen on these meta blockchains are asynchronously finalized again and committed back to Ethereum in bulk. But before we get started, let's first make sure that this makes sense, that it's sensible to start doing this. And so if you run a very simple toy model, Ethereum has 10 transactions per second it can process. If you would have 100 shards, each of them can have a modest 100 transactions per second. Then together they process 10,000 transactions per second. But now, assume you have 100 validators for each shard. They also all have to talk back to Ethereum, so you have 10,000 transactions to process on Ethereum minimally. And now that's at least 1,000 seconds. But at the same time, we've processed 10 million transactions on these 100 shards, or we've been 99.9% efficient. But we've also consumed all of Ethereum, and that's not what we want to do. So it's very clear to see that if we can scale the number of nodes, then the benefit scales linearly with that, but also our cost. The important remark here is that if we can actually reduce the cost as we add more nodes, then we get to a much more interesting situation. If we can devise a consensus rule system where we are not required on any time constraint to commit back to Ethereum, then we can drive our cost for committing back to Ethereum drastically. And so if you would only commit back once, then we've processed 800 million transactions at only 1.2% of Ethereum's existing capacity that we have today. So let's do it. Let's move everything off of Ethereum, all transactions off of Ethereum onto auxiliary chains. And so it's important to note that now we have two Ethereum interfaces, right? We have the EVM of the Ethereum mainnet, and each of these auxiliary chains also has an Ethereum EVM interface. But hold on, sidechains have been around for years. What's different here? So let's define what a meta blockchain is. It's a full blockchain with a consensus engine in a core contract on Ethereum. And each of those meta blockchains has an open staked validator set where the stake is also protected by Ethereum. And so the important proposal here is that the consensus rules of Mosaic are Byzantine fault tolerant, and they allow you to move block proposals off of Ethereum and onto the auxiliary chain. And as I said, one of the three ingredients is you also need a way to communicate between those shards. So we've developed a gateway protocol that we have typed for ERC20 tokens to move tokens in and out of meta blockchains. But all the original value, all the original tokens is guarded and protected by Ethereum mainnet. And so why tokens? If we look at how Ethereum has evolved, then de facto the functional unit of Ethereum today is a token. Tokens define applications, and to a large extent, they even define the interaction between applications. And what is very nice is that tokens give you a natural way to repartition the state space of Ethereum. So sharding at layer 2, we call it token sharding. We need two things now. We need a way to move tokens in and out of mainnet into these meta blockchains onto the auxiliary chains. And we also need a base token on the auxiliary chains. And so for that, we use OST. When you move it into the auxiliary system, then it becomes the base token that you can use to pay for gas. And so we've recovered a full native EVM interface where users pay for the gas that transactions consume. But we don't want to use this gateway protocol, or we don't want to have a gateway protocol where there's some oracle that transfers between the two chains, or even a validator bridge where validators need to sign off on the transfers between the systems. And so what you can do instead is, if you have knowledge of the state truth, the summary of the opposing chain, then you can prove with Merkle proofs what is true on the other side. And so that is what we have today on mainnet version 0.9.2, but here we still oracleize between the two chains. And what we do with Mosaic is decentralize that state truth transfer on top of the security properties that I'll talk to really make the gateway protocol consume these decentralized state truth confirmations and allow users and dApps to communicate between these meta blockchains. So a brief word on inter-blockchain communication. I think it was first introduced by Tendermint, Jae-Kwon, 2016. And so also my previous history was close relation with Tendermint. And so what is very important is that we want to create an open network where any message that is sent can always be completed by any other node. And so we've set up an incentive scheme so that any node is always incentivized to complete the full message transfer between meta blockchains. Or even to, if a user or a smart contract wants to revoke a message, he can still send out a revocation message. All that is already implemented. But tying it back up, so what do we have already? We have a way to divide the work into shards, and we have a way to communicate between those shards. But now we need economic finality on each of those shards. But that we already have. There's great work by Vitalik and Virgil from end of last year where they published Casper, the friendly finality gadget. And it's a consensus mechanism where validators can publish votes, and together they construct what we call a justified chain. And so a justified chain is a set of links, each building on top of the previous justified checkpoint, of a supermajority vote stating that this is the history the validators have chosen on blocks that already exist. And the interesting thing that I want you to know about this is that there is an additional way to assert that a checkpoint is finalized. And if a checkpoint is finalized on this justified chain, then it's proven that if the validators would want to opt for a different history, then more than 1/3 of their validators needs to sign a message that is contradictory to the messages they've already signed. And then the conditions of evaluating these contradictory messages are very easily enforceable. And so what we've obtained is a finalization mechanism on top of blocks, and we've taken away the power of the block proposers onto this layer 2 system. And so if we take those three ingredients and we bring them together, then we now have three blockchain systems. We have Ethereum mainnet, we have an auxiliary chain that runs as if it was a normal Ethereum chain, and on top of both of those runs Mosaic, which is also a proof of stake validator set. And remember that a block is intended as a way to communicate that we're moving the state from a state sigma to a state sigma prime. And so we define for a meta blockchain a meta block to be composed out of three parts. a kernel, a transition, and a seal. And so the kernel is quite easy to understand. I hope all of it is, but it has a height, a parent, as you'd expect. It has the update to the validator weights, and it has a gas price. And then the transition part has a dynasty number. And so for you, some of you may know this, but the dynasty number is in many ways like a height. Along the justified chain, it increases by 1 each time a checkpoint is finalized. And so apart from that, it also has the transaction route, the gas used along the justified chain, and then the seal is, as you would expect for a proof-of-stake system, a 2/3 majority vote that seals the block. So let's construct this. The Genesis block we know is committed by definition, and so what we automatically always know on Ethereum itself is the kernel. We know the height, the parent, the updated validator weights, and the gas price will have been voted on. And in parallel, and this is important, the two systems run asynchronously without any time bounding between them. We can finalize checkpoints. We can run and construct a justified chain with this validator set on the auxiliary system. And importantly, also in the smart contract layer, we can now calculate these transition objects. We can keep track of how much gas has been used, and we can keep, with constant amount of computation, keep calculating the transaction routes for the justified chain. And here the magic happens, because now for any finalized checkpoint, the transition object is already calculated, and anyone can use this to propose a meta block. It's the second part of the block, as we discussed, that you need to propose a block. And so anyone can propose a new meta block to be as a new block for the new height, and there can be competing proposals now on Ethereum. But it's important to note that because of the work we already do to create a justified chain on the auxiliary system, these are no longer competing histories. They only differ in the dynasty height, and so it's just a question of at which height or height and dynasty height in the justified chain will I close the meta block on Ethereum mainnet. And this can only happen once. Ethereum is sequential, so there can only be one block proposal that first has verified the 2/3 majority vote of the seal of the proposed block. And then the very careful watcher will see that our vote object has only slightly changed. We've added the transition object T to the vote object. And in order to do that, we only have to very conservatively update the slashing conditions. And what you want to note now is that these slashing conditions are enforceable on both chains. So if a violation happens of the slashing conditions, everyone is incentivized, and it's immediately possible to assert them both on Ethereum mainnet and on the auxiliary chain to make sure that the weight of the validator is brought to 0. But if we have sticks to beat validators, we need to give them carrots as well. And we already have extended the natural gas market of Ethereum. OST becomes the base token on the auxiliary system that users can use to pay for the gas cost of their transactions. And they're paying that to proposers, the auxiliary chain proof-of-stake proposers. And now we add a second gas market to that. The proposers themselves, they have to agree on a gas price that they're willing to pay to the validators of Mosaic for each block that gets committed onto Ethereum mainnet. And it's very interesting to note now that the validators of Mosaic, they're not rewarded for closing blocks or producing blocks. They're rewarded purely for the gas consumed and for the votes they have contributed on the auxiliary system. And so by construction, the validators must have voted on the auxiliary system and help to commit to Ethereum in order to get to their reward. But we also want to have a forcing function, and so we introduce a gas target. The gas target is a limit, a parameter that the system can change to force that the validators are required, once this target is surpassed, to the next finalized checkpoint must be committed onto Ethereum. And so this gives us a global coordination mechanism for the validators to join on Ethereum and commit the blocks naturally. And then each time a block is committed, that gives us a cycle in the system, and validators can deposit funds to join, or they can request to log out, and they can only do that after the second following meta block. This is very similar to the normal Casper logic for those who are familiar. Logic carries forward. But what if it all goes wrong? And this is also the value of being at a layer 2 system. Now it's very easy to recover from faults, because we know that any finalized checkpoint on the auxiliary system can always by anyone be committed as a block on Ethereum mainnet. And so validators can be challenged that the auxiliary system has halted. And for any halted core, rather than requiring a proof of redemption or a request of redemption and going through a lengthy process, it is now sufficient for presenting just an ownership proof of tokens to recover your funds on Ethereum, because they were always kept in a contract on Ethereum. And so there is no mass exit. If a user comes back 1 week after the chain is halted, he can recover his funds. If he comes back 1 month after it is halted, he can recover his funds. If he comes back 10 years, he can recover his funds. So we don't have that constraint that you would have in other systems. So tying it all up, by playing this continuous game of committing blocks back to Ethereum, we have a decentralized way to recover the state root. And now any dApp can deploy their own gateway protocols and consume these state roots to transfer their tokens or their stateful messages across these meta blockchains. And once we've constructed this system, now we can use normal atomic swap technology. We've already built this to much more faster and efficiently move across these meta blockchains and back and forth to Ethereum. And this is important because we want to have a load balancing logic across the shards. But importantly, we don't have to do this in the protocol. This can be off-chain logic for each dApp specifically, where it monitors the health of the shards and allows users to move across shards or recover back of Ethereum if they would deem it unstable. And lastly, I think this is a very fertile testing ground also for Ethereum version 2, because we can build this on top of Ethereum, we can test it. There's a lot of parallels, and I think that we will have a lot of learnings, hopefully in both directions, of how to also build these systems at the layer 1 inside the consensus engine of Ethereum. And so, as a final summary, we've derived the security of these auxiliary systems, and we've extended that from Ethereum proof of work in an asynchronous way. And it was really important that at no point there was a timeout or a time constraint in the logic, because it would both potentially undermine the security, but it also hinders the scaling. Because now the number of cores, the number of auxiliary systems Ethereum can support is only really bound by the total stake that is put against it by the validators. And that is naturally driven by the demand, because they are rewarded in gas, that users need to perform on Ethereum. And so we're confident that we can get to tens of thousands of transactions per second finalized on Ethereum and at a lower gas price. Because also the validators do not have to perform proof of work. We're leveraging the bits that we already have in proof of work to secure these systems, and they only have to verify transactions. So where we are today, we have 120 developer teams in hackathons on testnet. We have 12 external partners that have early started moving to mainnet. We've completed the messaging protocols. Right now, with the next release, we're focusing on the higher layer in the stack, namely the dApp framework that we're building to help companies tokenize. And we're also talking at events. So we're coming out with Mosaic, the work we've been doing over the past year. We're working on the implementation of Mosaic so that we know that at least it works. It might not be perfect, but we want to do that before we really make claims. And so at this point, we're confident, and we really value feedback from the community. And lastly, also want to give a huge thanks to the team and our community, without which we wouldn't have come so far already. And so what can you expect? So we're working on the first implementation, and then end of this month, so in 2 weeks, we'll publish the paper. Meantime, we're going to continue testing the larger stack and also onboarding more users onto testnet, and then eventually moving users also onto mainnet. And so beginning of next year, we launch alpha of Mosaic. Very shortly after, we'll start warming up the validator pool. And then we can start on exciting new work, is also how do smart contracts call between meta blockchains or these auxiliary chains. We have proposals for that, but no implementations yet. And then if we want to get to machine transactions, we can multiply this order of magnitudes again by putting auxiliary systems on auxiliary systems, whether that's then running on Ethereum as we have it today, or on sharded Ethereum, we're further multiplying the transaction throughput. And then we promise that the smart contracts by 2020 will fully unlock and release to the decentralized validator pool with a time lock in them. So thank you, and then open for questions. Yeah. We have 0 seconds left.
And we'll say we're doing this because we want feedback from the community. As I said, last Friday was the first time we presented all these details. We're doing it again 1 week later now. We're going to keep doing it. And we want the community to help us strengthen this so we can make this a viable scaling solution for the blockchain community. So thank you all very much.
Thank you very much, Mr. Goldberg and Mr. Bollen. So among the questions the audience has left, I'd like to ask, the first question is, could you describe one ideal utilization of OST?
Yeah, sure. So we have partners, a lot of mainstream companies who have turned to OST because they want to create a blockchain economy, so a new economy around their community or around their ecosystem. They don't want to do their own ICO. They don't want the legal regulatory headache involved with that. But they do want to have a token, and they want to be able to tokenize certain events inside their applications. Our partners today, I mentioned the company Unsplash. Our partners today, there's other companies at very large scale. Together they combine to reach over 300 million end users, and we're adding new partners every week. Next week we have another major partner announcement. And essentially what they want to do is they want to use our technology, our infrastructure, our developer tools, and eventually our wallet and exchange in order to create branded token economies that are used to incentivize actions and events, micro events, and create micro economies around their communities. And basically for them just to use OST as the base technology and base token and able to do that at scale.
Thank you. And the next question is, what is the technical plans for protocols communication among meta chains?
So I'll take that one, Jason. So I've hinted that we have early designs for that. So right now, it's a hub and spoke model between Ethereum and the meta blockchains for going through the gateway. And then I mentioned that because they're tokens, you can actually, once they're constructed, use any of the existing atomic swap technology to move directly between Ethereum mainnet or the auxiliary chains. So that is all, I mean, by default already there. Well, you do not have a smart contract calls between meta blockchains, and for that you want to repeat the same logic. You want to actually have a validator set on the auxiliary chains that runs the finalization game, the justify chain on the respective chains, and it can do this now at a much higher speed, and then you type a specific gateway, same base logic but differently typed, for smart contracts to send a message through that gateway. It consumes at a much higher rate the state root transfers between those two chains, and it can even have a callback of the result asynchronously to the original contract.
Okay, and this is the last question for you. The next one is, how would OST accelerate adoptions? How OST is building its own community?
Yeah, so it's a great question, and it's also an essential part of our ethos is to build with the community. So earlier this year, we started a series of alphas, public alphas, where we invite the community of developers to touch early versions of the OST technology and to use the protocol, to use also the developer tools on top of it. So we have a very robust developer APIs and SDKs at dev.ost.com. And what we've been doing is having every couple of months a series of developer challenges. So we have, as Ben said, there's 120 plus development teams who have built integrations into their own apps using OST already. So we're talking about app developers who either have an existing app, a mainstream app that they are integrating basically taking events in their app and triggering token transfer events on the blockchain, as well as brand new apps, as well as dApps that are being created from the ground up. And then what we do is, in addition to working with the kind of public open developer community, we also work much closer with a series of larger partners who have millions or tens of millions of users, and we have blockchain strategy consultants who work with them on planning their token mechanics, token design, the token economies, and then working on their implementations, and eventually even their smart contracts. But the community is everything. So our goal is to have several thousand developers building on OST and informing the roadmap over the next year. And we'll be doing more alphas and beta tests over that period of time. And anyone who wants to start playing with in developing on OST, just go to OST.com. We can get you whitelisted into our sandbox environment. You can be staking OST and minting a token in a matter of seconds, minutes, and then we'd love to get your feedback on it.
So for the sake of time, I think we need to close the Q&A session here.
Awesome.
So thank you very much for sharing knowledge and information with us. So you can.
Thank you. Thank you so much. Thank you.